Hello, everyone. My name is Chang Lu. Welcome to this course, which is called Optical Properties of a Material. I'm a professor from Department of Photonics, National Yangming Jiao Tong University. And okay, so this is my office. My office is in the Tin Ta Ping Photonics buildings, EO3168, and this is my email. And all of my course information is on the eCampus 3.0. And I suppose you have received some emails from this system. And actually, I have put all my lecture notes on this eCampus 3.0, and you can download them and as your course materials. Okay, first of all, I would like to briefly introduce my lab. My lab's name is Advanced Nanophotonics Lab, and this is the address of my lab. So if you are interested in what we are doing, you can click on this link. And of course, we have also the English versions, and you will see the some related research of my lab. And actually, I can tell you that most of my research works in the lab are related to the optoelectronics, especially semiconductor lasers. So in this web page, you will see all kinds of lasers, including like the vertical cavity surface emitting lasers or photonic crystal surface emitting lasers. And in the recent years, we are also doing some very interesting topics like the surface plasma polariton nanolasers, which is the smallest laser in the world, and we also hold some world records in terms of the operating temperatures and the mole volumes, etc. And we're also doing some interesting work like the strong coupling between exciton and the photons. Uh, the way we are doing this is try to use the microcavities with very high Q values. And these microcavities is resembled to the Vic cell structures, which has two high refractivity mirrors sandwich one active medians, and which is always we put like the excitons in there. So in these structures, excitons and the photons that has been tightly confined between these two mirrors will interact with each other and then form a quasi-particles called exciton polaritons. And it turns out that exciton polaritons is a kind of the bosons, which we are going to mention later. And the boson has a very interesting characteristic is that it can reach the Bose-Einstein condensations, which is a kind of coherent forms of the materials. Maybe you have ever heard of like the superconductors or the superfluids. Okay, but typically superconductors or superfluids can only be observed at a very low temperature, like several nanokelvins or even a lower temperature. But if we couple the exciton and photon together, we are able to realize a very high temperature Bose-Einstein condensations, and we are the world record holders, which that we use the zinc oxide exciton coupled with the photons, and the systems we created is called the exciton polaritons can reach the Bose-Einstein condensations or the superfluids and at the very high temperature at 80 degrees Celsius. Okay, so that is also a very interesting research topics. And we're also doing some material related works like we are investigating the perovskite materials or the 3,5 compound materials or 2D materials, so on and so forth. Okay, and we also do some research in related to the light-emitting diodes. Okay, but recently we are most focusing on the light-emitting the laser diodes research. So if you are interested, I encourage you to see what we are doing recently. So for example, like here, we published a paper in Advanced Science 2020 that is about the current modulation of plasmonic nanolasers by breaking the reciprocity on hybrid graphene insulator metal platforms. Although there are so many keywords, but I'm sure that in this course, in this semester course, I'll teach you one by one what the meaning of this very special keywords is, and I hope you are going to learn a lot in this course. Okay, so what we are going to teach in this course. This course mainly deals with the optical properties of the solids. Okay, so the uh, the subject is the solids, but we are mainly talking about the optical properties of solids. But although we will describe some electrical properties of solids, but the purpose of here is to see the optical properties of solids. Okay, so in this course, we will start from the very simple concept from the classical physics. Okay, so we will start from the classical description on the very simple phenomenon on the optical transmission, optical refraction, and the optical absorptions. Okay, and that is totally classical and a very commonly seen phenomenon in your daily life. Okay, but we will start from these classical descriptions and then we'll try to teach the quantum descriptions on the absorptions and emissions of photons from materials, okay, and apply them to explain various interesting effects of interactions between light and different materials. Okay, so from the very beginning, this sentence is that our course mainly deals with the optical properties of the solids, and these optical properties actually is the light, and these solids means that there will be a different materials. Okay, so to be simply put is that this course is going to teach you various interactions between light and matter. Okay, so this is a very important keywords is that in this course, what we are going to learn is the interaction between light and matter. Okay, so these two main characters will be mentioned again and again. So you have to know, okay, in the later on, how the light interact with materials. We will start with classical descriptions and then try to describe it in by using the quantum mechanics. Okay, and then we will try to use the semi-classical treatment to describe or to teach you how to deal with the light matter interactions. Okay, so speaking of the materials, what kinds of the materials we are going to describe in this course? The materials includes, of course, uh, the materials we are interested in is the solid. Okay, so these materials will include semiconductors, metals, okay, low dimensional materials like the graphene or the recently introduced 2D materials, insulators, okay, which is typically the bulk materials, amorphous materials such as like the organic materials and the glass. Okay, but in our class uh, we will not mention a lot the organic materials because I'm not the experts in the organics, but we'll briefly introduce the basic or fundamental concept of this. Okay, and we will in the later chapters we'll focus more on the semiconductors, metals, and insulators. Okay, this is a very important how to say the the boundaries of the what we are going to learn about photonics. So you can see that at the very in a very small range or the areas lies the ray optics. So what is the ray optics? The ray optics actually is the geometric optics. Okay, 几何光学. So ray optics deal with the light that is limit of the wave optics when the wavelength is very short in comparison to the size of the materials. Okay, so we treat rate as a straight beam. Okay, we treat rate as a straight beam. So we will see that the ray will propagate in a straight line unless it encounters an interface. Okay, so when it encounters interface, you will see the reflection, you will see the transmissions. Okay, depends on what is the incident angles of this interface with respect to the incident light, and how it reflects should follows the refraction law. Okay, and how it refraction. Okay, refraction depends on the refractive index of these materials. Okay, so you can use only the very simple Snell's law and the refraction law, and you are able to describe the whole situations in the ray optics. Okay, although it's very simple, but it is also very important in the optical design. If you want to uh, design like an optical systems, like the lens, projections, or is the camera systems or the detection systems, ray optics can provide you all the information, all the tools you want. Okay, but it only deals with the limits of the wave optics when the wavelengths can be assumed to be very, very short. Okay, so this domain of knowledge is relatively small because it cannot deal with something like if the wavelength is close to the materials, okay, or if the material size is close to the wavelength. So in that case, diffractions, okay, and deflections cannot be explained by this geometric optics. So in that case, we have to deal with the wave optics. Okay, so wave optics deals with a relatively larger area than the ray optics. And as a matter of fact, the wave optics is a scalar approximations of the electromagnetic wave. We know that electromagnetic wave actually is a vectorial, is a vector. Okay, so it deals with the vector of the electric field and vector of the magnetic fields. We all know that light is an electromagnetic wave and it contains the vectors of the electric field and magnetic fields. Okay, but when it is too complicated, we try to approximate this vectorial characteristic. So we approximate it as a scalar. So in that case, okay, in that case, we are talking about the wave optics, okay, like the diffractions and the refraction. Okay, so this is the wave optics domain. It's slightly larger than the ray optics. So when you deal with the light as a full vectorial electric field and magnetic field, so in that case, we are further extend our domain knowledge to the EM optics. EM optics means the electromagnetic wave optics. We treat the lights classically and the material classically. So what does it mean? We treat the light classically and the material classically. The light is described by the electromagnetic wave. And this is, of course, the pure classical treatment. So what we mean, the classical is in contrast to the quantum mechanical treatment. Okay, so the things we are not treating it in the quantum mechanics, we treat it as classically. So if we treat it quantum mechanics by using the quantum mechanics equations, we say that we treat this system quantum mechanically. Okay, so how do we tell we treat these systems classically or the quantum mechanically? Just by whether we are using quantum mechanics equations or not. So of course, if we are using the electromagnetic waves to describe the light, how the light propagates, how the lights behave, of course, light is treated classically. Okay, so here, when we want to see the light interact with the material, and if this material is also treated classically, which means that we don't use the quantum mechanics to treat the material. So in that case, the light and material are both treated classically. That is in the domain of EM, electric and magnetic waves optics field. Okay, so maybe you will ask, how do we treat material classically? So what does it mean? This means that before the invention of the quantum mechanics, or before we know the materials actually is composed of atoms. Okay, so how do we treat the materials? Maybe some people, okay, will treat materials as a particle, as a big particle, or as a big uh, subject. Okay, so here, when the classical scientists before the invention of quantum mechanics, when they try to describe the light matter interactions, they will treat the material as a very, the material actually is composed by many small oscillators. So what does it mean by oscillators? Oscillators is a small spring. Okay, so it uh, oscillates or it swing up and down with a certain frequency. Okay, with a certain frequency, just like a harmonic oscillator. Okay, like a spring. Okay, like a spring, swing up and down or oscillates up and down. Okay, so we treat the materials like it composed of many springs, and then it interact with the light. Okay, so uh, in that way, we describe the materials in a domain knowledge that is called the EM optics. Okay, and if we further want to see a more complicated or more accurate descriptions of the materials, we have to introduce the quantum mechanics. Okay, we already know that actually all the materials are made by atoms. Okay, and in the atoms, we have many structures, we have many components, like the nucleus, and carries the positive charge, and like the electrons carries the negative charge, and there are a lot of orbitals with each own distinctive energy levels that electrons can occupy. Okay, so when the lights interact with these atoms, actually most of uh, the phenomena we are interested in the photonics actually is the lights interact with these electrons, and especially the valence electrons. What is the valence electrons? The valence electrons means that the outermost electrons occupies orbitals. Okay, so the outermost electrons, the valence electrons, interacts with these photons. Okay, so these phenomena is actually composed of many interesting and many complicated, many fascinating phenomena we are interested in. Okay, so in that case, we treat light still classically because we still use the electromagnetic wave to treat the light. But in terms of the materials, we use the quantum mechanics to treat these materials as atoms. Okay, so in that case, the light is treated classically, but the material part is treated quantum mechanically. So in these situations, we call it as a semi-classical treatment. Okay, so here is the semi-classical treatment. So it extends more and it can explain more phenomena when it compares to the EM optics. And of course, we know that quantum mechanics in the nowadays is the final or is the most accurate theory in the world. Okay, what we have learned right now. So the lights is originally treated classically. Maybe you will think of that. What if the light is treated quantum mechanically, right? Of course, you can do that. So when the light is also treated quantum mechanically and the material is treated quantum mechanically, we say that it is called the quantum optics. Okay, so we treated lights and the materials. They are both using we are both using the quantum mechanics to treat these two main characters all together. Okay, so it can describe the most accurate. It can cover the largest phenomena we are able to think of. So this is called the quantum optics. Okay, so this is called the quantum optics. It covers the largest area of this field, largest area of this field. Okay, so in our departments, Department of Photonics, we have course about the ray optics. Okay, in the geometric optics, we have a course described of the wave optics. So in this course, the main knowledge we are going to teach will cover the EM optics, okay, and the semi-classical treatments. Okay, so the largest knowledge domain we are going to teach you will limit to the semi-classical treatment. Okay, will limit to the semi-classical treatment. If you want to know more details about what will be the most accurate methods or uh, formulas to see the light matter interaction, I strongly recommend you that after this course, you can go to take one course. The name is called the quantum optics. Right now, I believe it is opened by Professor Zhisheng Wu. Okay, maybe this semester I'm not remember that in one semester he's going to talk about a more complete descriptions of the quantum optics. Okay, quantum optics. If you're interested, I encourage you to take that course after this course. So this course provides you a fundamentals or the intermediate course between the classical optics and quantum optics. Okay, so we are dealing with the things that is in between. Okay, then I'm going to talk about what the text we are going to use and the grading policy and the other informations, so on and so forth. Okay, so first of all is that what is the textbooks we are going to use is this one, optical properties of solids. Okay, so I believe that it's right now it's only the second editions. Okay, and this books is written. The author is Mark Fox. Okay, Fox, which is a British professor. Okay, the publisher is Oxford University Press, and I strongly recommend you buy these books. Okay, the reason is that most of the examples and most of the homeworks are coming from these textbooks. This is the first reason. The second reason you can see that these books actually is not so thick. Okay, and if you can open these books, you will see that there are actually not many equations in these textbooks. So what does it mean? It means that it is written in a format that's try to help you understand more about the physics. Okay, so the author doesn't want to like try to uh, give you very difficult time in realizing the difficult mathematics equations or the physics equations. Okay, so that is one merit, one advantage of reading these books. Okay, so it will help you to understand the physics without using too many mathematics expressions. Okay, and second, because this author from the UK, which means that the English he used is very, very uh, excellent. What I can say is very, very excellent. So actually, reading his paragraph or the textbooks actually is a very enjoy moment. Okay, you will not be how to say defeated. I should say this. I admit that some textbooks are written very, very bad. Okay, so sometimes if you don't, if you cannot, learn these textbooks or read these textbooks very quickly, or you just don't understand what this textbook is talking about. Maybe it is not your fault, or maybe it's not because you are not you are not so smart. Probably it's because the textbooks actually is written very bad. Okay, textbooks is written very bad. But these textbooks is very, very excellent. Okay, so that's several reasons I persuade that you should buy these textbooks. You should buy these textbooks. Okay. Oh, of course. And uh, the lecture notes I arrange is basically follow the chapters. Okay, it's basically follow the chapters listed in these textbooks. Okay, so if you have these books, that will be very helpful. And the other textbooks I'm going to use is a very classical one. It's called the Semiconductor Physics and the Devices. Okay, and right now I believe it's more than fourth editions, maybe fifth or even higher. This is written by the Neiman. Okay, Neiman. So here the fourth edition is published in 2011. Actually, this book is what I used when I was in the undergraduate study when I was a college student in maybe the third year. So this is like more than 25 years ago. Okay, more than 25 years ago. I still keep these books. So I'm going to use this from maybe chapter from the first two to first maybe 1 to 5 chapters to teach you the concept of the semiconductors physics. Okay, to teach you the semiconductor physics. And of course, these books is often used by the professors who teach the semiconductor physics uh, or the solid state physics or the solid state physics. Okay, so this books is also very important one. And of course, we have already put my class notes and the reference on the eCampus 3.0. Okay, but the class notes are published in the eCampus 3.0. There will be some blanks, okay, without any typings or the characters in the lecture notes. And with those blanks, I just want you to write down the missing part. Okay, the missing part. Of course, the complete lecture notes I will show you during the class. Okay, so the purpose of these blanks is just try to keep you awake. So when you are listening to this class, and you can sometimes writing down some important notes, and that can keep you awake and be focused on the class. And of course, if this when you write down this missing parts takes you a lot of time, the easy way is just take a snapshot of it. You store the pages when you watching the videos, and then later on you can write those notes into your own notes later on. Okay, so these are the three important texts I'm going to use. And the following is the grading policy. Okay, so I will have the assignments and homework or the homeworks I will assign regularly. And this homeworks actually is very important because it takes 40% of your final score. Okay, 40%. Okay, 40%. And for these assignments, I will usually assign at certain uh, dates, and you have to turn in after 2 weeks. Okay, you have to turn in your homework after 2 weeks. And because I would expect that in these semesters, all the course will be an online format, So please turn in the electronic files. Okay, please turn in the electronic files to the eCampus 3.0. Okay, so you can write it down as a handwriting and then take the pictures, store it, or save it as a PDF files and uploads to the eCampus 3.0. Okay, uploads to the eCampus 3.0. And of course, you cannot copy others homework. If our teaching assistants or I found that two of the your answers are identical, okay, then you will get no points at all, both of you or some of you, some of you. So please be sure to write the assignments or homeworks by yourself, okay, by yourself. This is the important things you have to know first. And then if you have to turn in your homework on time, okay, on time. If you turn in late, okay, like 1 day late, you will the this your homework will be subtract 10 points, okay, 10 points of that homework. If you are turning later than 5 days, okay, then you don't have to turn in anymore because you will get 0 points. All the homeworks will be 0 points. You don't have to turn in anymore. Okay, so please turn it on time for your homework, and please do the homeworks by yourself. Okay, then following is the quiz. As I mentioned, that I expect all our semesters will be an online format. Okay, so which means that uh, I will give you a very quick selective quiz. Okay, selective quiz at the end of the at the end of each week. So that is Wednesday afternoon. After Wednesday afternoon, I'm going to give you a quiz, and this quiz cover the contents that I taught in the previous weeks. Okay, so this quiz cover the contents I told you in the previous week. So please be uh, on the at the end of the Wednesday course. Okay, before that, please be prepared, and this quiz will take 5% in your total score. Okay, in your total score of these whole semesters. Okay, then following, we will give you two exams, and these two exams are all open book. Okay, so why there are two exams? One exam is all about the review of quantum mechanics. Review of quantum mechanics. This exams, uh, I give you this exam is because that I want you to review the quantum mechanics. Later on, I will introduce that. I will tell you that we will going to give you a supplementary extra course that is offered by our TA teaching assistants. And the teaching materials is already on the eCampus 3.0. Okay, so it is in the reference part. And I already give you the lecture notes. I already give you the lecture notes. And I will ask the teaching assistants to give a 4 weeks, 4 weeks extra, um, extra teaching on the review of quantum mechanics. Okay, so after that review of quantum mechanics course, extra course, I'll test you. I'll give you an exam about how you are familiar with the quantum mechanics. Okay, but unfortunately, this quantum mechanics review of quantum mechanics is offered by the Chinese speaking teaching assistants. Okay, so I know that some of you are not native speakers, and I'm sorry that you have to read the uh, lecture notes review of quantum mechanics by yourself. Okay, by yourself, and you have to still attend this uh, exam. Okay, because it takes 10% of your final score. It takes 10% of your final score. Okay, following is the midterm. Okay, that is very straightforward. It's just a midterm. Okay, it's just a midterm, and it takes very uh, substantial portions of this final score is about 20%. Okay, it's 20%, and it's also open book. Okay, but I'll remind you that although I call it as a midterm, actually it will be held at the very later times of this course. It will happen at a very later time of this course. So this midterm actually is very close to the final. So it covers the very large portions, large contents of this course. Okay, so that is very important part of the final score. And then is the final report. Final report takes 20% of your final score. Okay, of your final score. So the way I want this final report to be held is that please try to find 2 to 3% to form a group. Okay, 2 to 3%, no more than three. I don't want 4 persons in a group, and I also don't want 1 person in a group. Okay, so please find another one, or please find another 2 person to form a group, and then you have to find each of the group. You have to find an paper, and this paper is SCI papers. Okay, and the content of these SCI papers have to be related to this course. Okay, have to be related to this course. Okay, so after you decided the SCI papers you are going to report with your team members, you should turn in your titles, your report groups list, and the title of this SCI papers and the papers itself to me. Okay, so later on I'll send you the dates. The dates you are going to submit this information, because I have to give you a permissions if this papers is suitable or not, or if this papers is related to this course or not. Okay, so after you did, so what I suggest is maybe you can find several papers, and then decided 1 to 2 papers you are going to report the most, and then send those papers to me. Okay, and I'll check if these papers is okay or not. Okay, now after I permit the papers you want to report, then you prepare the presentations. Okay, you present the presentations, and these presentations, of course, has to be the English. You have to report it by using the English. Okay, and you don't have to turn in the written report. All you have to do is do the presentations and answer my questions. Okay, so how do I give you the score of your final report is based on the way or the correctness of your reply to my answer. Okay, so the way how I execute, or how you perform the final report is that you make the presentations in English, maybe in 10 minutes or within 12 minutes. After that, I will ask each of you, okay, one by one, just one questions, and then you have to answer me the answers as soon as possible, and I will grade your score based on how you answer these questions. If you answer it right, you will get more than 90 points. If you answer it wrong, or you don't know how to answer, or you just say, I don't know the answer, you will get 70 points. Okay, and of course, if you answer part of your answer is correct, or part of the answer is not correct, your score will in between 70 points to 90 points. Okay, so all the points will range from 70 points above. If you answer it very correct, maybe you will get higher than 90 points. If you answer it wrong or have no answer at all, you will have 70 points. 70 points. Okay, and that score is only belongs to you. So which means that when I ask you questions, you cannot discuss with your teammates or discuss with other classmates in the classroom. Okay, because this is a test. This questions is only for you. You have to answer me the questions, and of course the questions I'm going to ask were related to the papers or the contents report. And most of the questions I'm going to ask actually is the content I taught in this course. Okay, so I'm not going to ask the questions that is not within this within the contents I taught in this is not within the content I taught in this course. Okay, so all the course is all the questions were related to this course. Okay, so it is kind of final exam, but you have only one questions, only for you, only for you. Okay, so I will ask each of you one questions one by one, and then I'll give you a score. Okay, and there's a one bonus is that the one who make the presentations will get extra 10 points. The one who make these presentations will get extra 10 points. Okay, but maybe you you will send in your team, you will send out two persons to make these presentations. Okay, and then I will give you each of you 5 points and 5 points for bonus. And of course, and if you are if your teams contains three persons and the three of you they are going to make the presentations, and of course I will give you 3.3 points each of you for the extra bonus. Okay, but these points is the highest points I'm going to give you the bonus. If the presentations report is not so good, okay, what does it mean by not so good? Uh, if your presentations is very lengthy over the time I ask you to report, or very short, okay, before the time ended, you just finish, or if there's a lot of mistakes, or if the how to say the styles you make is not very appropriate, okay, or the presentation is not so smooth, okay, so in that case you will not get the full bonus points. Okay, so I will subtract a little bit if you not doing very well in the presentations. So this is for the bonus part, and that is your final report score. Takes 20% of the final scores. And finally is attendance. Okay, so here, how do I define the attendance if all the course will be an online course? Uh, okay, so it depends on you. Uh, at the end of at the end of each course, at the end of each course, I will give you time to ask questions about the content I give you on the video. Okay, I give you on the video. Okay, so if you ask questions, I will give you bonus. Okay, I will give bonus. And if and that this format can be also like I ask questions in the end of each course. And if someone can answer that questions, I will give you extra points. Okay, that consists of your attendance score. That is 5%. Okay, that is 5%. So I encourage all of you after each video, at the end of the course, please ask questions, or I ask questions and pick up someone to answer. If that one no show, not attending this course, then you will be subtract 1 point. Okay, you will be subtract 1 point. Okay, so that is how I grade the attendance. It takes 5% of your final score. Okay, so total is 100%. Okay, total is 100%. Following is the related activities and the supplementaries will all be announced and given on the new eCampus 3.0. Okay, so if I remember right, previously there's a old eCampus 3.0 and the new eCampus 3.0, but right now I believe there's only one. It's called the eCampus 3.0. It's all new. Okay, so please look onto the new eCampus 3.0 to find out what are the extra activities and the supplementary. So our course time is one Monday EF and the Wednesday H. Okay, so probably I will use the Google Meet. Okay, I will use the Google Meet, and please every week, please join the Google Meet. And in the Google Meet, I will give you the video links of our course, and then you watch the videos. Okay, and each videos probably will take 45 minutes. Okay, so for example, on Mondays, I'll give you two links. Okay, so you will read and see those videos by yourself. And after that, I will set up a time. You come back. Okay, you come back, and you come back to do what? To ask questions, or be asked questions, or I will raise some questions for you. Okay, and on Wednesday, of course, again, I'll give. Please attend the Google Meet, and then I'll give you the video link and ask you to watch that videos. Okay, it's about like the 40 minutes, and then ask a question. It's a question time. After that is the quiz time. Okay, after that is a quiz time. Okay, so that is how course I'm going to proceed in this semester. And if you have extra questions, I have an office hour. It's in the Tuesday afternoon, 1:30 p.m. to 2:30. Okay, uh, please uh, come to my office by appointment. That's a more proper way. Okay, it's a it's a much proper way to do that. But of course, if you just pass by and see I'm in the office, you can also knock the door and see if I have time to discuss with you, or you can ask questions. Okay, so this is all the important course informations I'm going to give you. Okay, then is the teaching assistant. Teaching assistant is Huang Zhenting. Okay, his English name is Zhenting Huang, and his email is as follows. Okay, so if you have any questions about this course, like the supplementary course on the review of quantum mechanics, uh, questions about anything, you can contact Zhenting, or you can directly contact me. Okay, and in the following, I'm going to give you some reference, give you some reference if you want to know more about this course. The first reference is this one, Physics of Optoelectronics Devices. It's written by Professor Zhuang Shunlian. Okay, Zhuang Shunlian used to be the professor in UIUC. He's a Taiwanese. Okay, he is a Taiwanese, and but unfortunately he passed away several years ago. But he left a legacy. So what is the legacy? These books. Okay. As a matter of fact, this book is an old one. Okay, I bought it in 1997. So this is also more than 20 years. And he published the second editions. He published the second edition, and this books actually is very difficult. This book contains many quantum physics, okay, related to the optoelectronics. Okay, so if you want to know more details about the formulas I give in this semester's course, I strongly recommend that you read some details about those equations in these textbooks, in this reference. And second is, if you want to know more about the quantum optics as an introduction, okay, you can also read these books. Is also written by the same author of our textbooks, Mark Fox, and he followed his style to introduce the very difficult physics, or like the optical properties, okay, very difficult things, by using a very easy, and try not use too many mathematics formulas, and try to introduce those concepts to you. Okay, so if you want to know more advanced topics, I strongly you buy these books, and it's really worth it. Okay, the other one is all about the solid state physics. Okay, so you can try to read the optical process in semiconductors by the J.J. Penkov. Okay, but this one is relatively old books, and the other two books is very hardcore. Okay, which means that they are classics. They are very classics, and has many basic and fundamental formulas of the solid state physics or the semiconductors. So first one is the Peter Yu and the Cardona, okay, which is the which are the professors from UC Berkeley. Fundamentals of Semiconductors. Fundamental of Semiconductors. Or this Archcraft and Merman solid state physics. Solid state physics. And these two actually, again, are not so easy. Okay, are not so easy. But during the class, if you want to know more about the solid state physics, I strongly encourage you to read these two books. Or you can choose another easier one. This is written by the Phillips Hoffman, okay, solid state physics. As you can see, this is very thin, okay, this is very thin. So, which means that it's easier to understand, okay, it's easier to understand. So, if you want to know the fundamentals of the solid state physics, I encourage you buy one, okay. So, this is actually the books that publish give me as a gift. Okay, they gave me as a gift because I helped them review very complicated textbooks. And finally, it's a Chinese book. It's called Introductions to Quantum Mechanics. Okay, Introduction to Quantum Mechanics. Uh, this book is written in Chinese, and in my opinion, it is a very good book. Okay, so if you want to review your quantum mechanics, and or if you uh, after reading our extra uh, teaching, extra descriptions of review of quantum mechanics, if you want to know more details, I very strongly okay recommend you read these textbooks. But unfortunately, it's only written by Chinese. However, for the non-native speakers in Chinese, I pretty sure that there are a lot of very good books on quantum mechanics. Okay, but that most of them are very thick. So you will try to find many examples and contents in that books. Try to help you review your quantum mechanics. Okay, so why I mentioned a lot of quantum mechanics, it has nothing to do with the optical properties of materials, right? But I'm sure that in the previous course descriptions, you already know that the uh, the domains we are going to talk about is the light-matter interactions, and we want to treat the matter quantum mechanically. Okay, so what does it mean? It means that we treat our system, light and matter, semi-classically. So which means that we have to use a lot of quantum mechanics in this course. Okay, so this course actually is an advanced course above or follow the quantum mechanics or the modern physics. For the undergraduate students, you already learned the modern physics and the quantum mechanics in the previous semester. Okay, so this semester is the best time, is the best situations for you to familiar or to understand how you apply those very uh, abstract concepts in the quantum mechanics to the real world, to the real physics problems. Okay, so this course actually is very important for you to familiar with those formulas in the quantum mechanics. How to apply them is very important. Okay, so these are the references. Okay, so finally is our syllabus. Okay, so the whole semesters there are 16 weeks. Okay, there are 16 weeks. We will arrange the chapters from chapter 1 to chapter 9. Okay, to chapter 9. We'll finish from chapter 1 to chapter 9 in 15 weeks. And the final weeks is the final report. Okay, the final weeks is the final report. And as I mentioned previously, there will be two tests, okay, two exams. One I plans to have is on November 15th. The other one is the midterm. Okay, November 15th is the test on review of quantum mechanics, 2 hours. And the other one is our midterm. Actually, you can see that this midterms is held at the 13 weeks. It's almost finished our semesters. We only have 2 weeks left for teaching other stuffs. Okay, so I would say that this midterm is almost the final. Okay, but of course this is open books, and the supplementary will be held on the third weeks to the 6 weeks. Okay, that will be done by our teaching assistants, and I think there will be also an online version. Will be and also an online versions. So please be noted, we will put those informations and online this video, this Google Meet links on the eCampus 3.0. Okay, so this is how I arrange the whole semesters from week 1 today to the end of our semesters. Okay, so if you have any questions, I'm very happy to answer after this video. Okay, thank you. Bye bye.